Good morning, good afternoon, everyone. This is again Miss Marte and Miss Slavnika, and we will be talking about solving linear systems by elimination, which is another algebraic method to solve linear systems. Good. So in order to do that, we will be looking at this system. X plus 2y equals 8, x minus y equals 5. What am I supposed to do, Miss Slavnika?
Well, elimination means that you will eventually eliminate either x or y variable, and it can be done by either addition or subtraction of two equations. So looking at this system, I think it will be the easiest to eliminate x variable by subtraction. So if I subtract 1 minus 2, and that means I'm subtracting second equation from the first one, I simply follow the subtraction step by step. So x minus x is 0x.
X minus x is 0x, right?
2y minus negative y.
Okay.
And 8 minus 5.
8 minus 5. Okay. So look what happens here. X minus x is gone, so it is eliminated. Correct?
That's correct. So now we have a 2y plus y is equals 3. So the 3y is equal 3. And therefore, y coordinate of a point of intersection is 1.
Good. Okay, but I need a second one, which is I need x. So what do I do to find my x?
Choose one of the given equation.
For example, which one should I choose? Number 2, for example?
Sure, choose number 2. The coefficients for x is 1, coefficient for y is negative 1, so it's easy to substitute y value 1 for y. So,
okay, so x minus 1 this time equals 5, x equals 6. So the point of intersection as an ordered pair is 6 and 1.
That's correct.
As usual, whenever we solve a linear system algebraically, we also want to solve it graphically. So here it is. Let's bring it to the front so we can see it nicely. Okay, so Miss Slavnika, help me please. Which equation is the blue one?
The blue equation is number 2.
Blue is number 2.
And the red line is number 1.
Okay. So
and as we can see, they do intersect at the location of 6 and 1.
Okay, excellent. Good. So this seems very easy. Let's go to a more complicated situation, the one that I have right here on the board. This time I look at equation number 1, I look at equation number 2, and if I do 1 minus 2 or 1 plus 2, I won't be able to eliminate either of the variables. So what do I do?
Well, what we will need to do, we will need to create same coefficients for either x or y.
So you mean these 3 and 4 must be the same?
Yes. And if we want to look at elimination by addition, these two coefficients has to be identical but opposite. So what we will do, we will multiply first equation by 4.
I'm going to multiply by 4.
And second equation by negative 3.
Okay, so I am going to multiply both sides of these equations by 4 and negative 3, and I will get equivalent equations. Am I correct?
Yes, you are right. We could have picked multiplication by negative 4 for the first one and by positive 3 for the second one. We will accomplish the same task. So the second equation, as we can see, multiplied by negative 3 is giving us for a x variable same coefficients but opposites.
Okay.
And what we will do, we will now add these two equations.
So I'm going to add 1 and 2, and let's see what happens. 12x plus negative 12x is gone. Nothing.
Yes.
16y plus 15y must be equal to negative 4 plus 66. As a result, 31y equals 62, so y equals 2.
Correct.
Excellent.
And now we need to calculate the x coordinate of a point of intersection.
So I'll go to equation number 1. Are you okay with that?
Perfectly fine.
Okay, 3x plus 4y equals negative 1. So now my y is 2. So 3x plus 8 equals negative 1. 3x equals negative 1 minus 8. 3x equals negative 9. As a result, x equals
Negative 3.
And
therefore, the solution for the given system as or a pair point of intersection is negative 3 and 2.
point of intersection. Excellent. Okay, now let's check graphically. Do we have the graph? Maybe a little bit later. Do I have another method to solve this system? For example, can I eliminate y? What would I need to do? Again, I need to make this in order to eliminate y, I need to make the y coefficients the same, maybe opposite sides. Any suggestions, Miss Lavnika?
I would multiply first equation by 5.
Okay.
And I will multiply the second equation by 4.
Okay.
So by doing it, I'm going to create a new system of equations.
Okay, that is equivalent to my given one because I multiply both sides of my equation. Nothing is changed there.
And what I will accomplish for a y to have a same but opposite coefficients, and in our case it's a 20 and negative 20.
Okay.
And now just simply add both equations together.
Okay, so if I add 1 and 2, what will happen here? 20y and negative 20y will cancel out. So we will leave you to finish this. Do you expect to get another point of intersection from this one, Miss Lavnika?
No, the solution has to be identical to the previous one. We just simply picked a different variable to eliminate. And if we want to check it graphically,
can you help me? Which one is the first one?
The first one will be the blue line.
One, okay.
And the second equation will be the red.
Okay, so feel free, if you do not believe us, feel free to use graphing technology to check or do it by hand. What we want to show here is that the point of intersection is, what are the coordinates of the point of intersection?
Negative 3 and 2, as we calculated it algebraically, we confirmed graphically.
Okay, thank you.